So another important aspect of the chapter on straight line graphs is to be able to write the equation of the straight line graph in the form y equals mx plus c. We call this the standard form of the straight line equation, and we don't really ever have to have our line in this equation in this format unless we firstly told to, or secondly we don't have a sketch and they want us to find the gradient of the line. So we need to remember the following information. When the equation is in standard form, the coefficient of x, or the m value, will tell us the gradient of the line. So if you're working with lines that you want to know what their gradient is, then you need to put the equation into standard form. Also, when your equation is in standard form, the c value, or the constant, will tell you what the y-intercept. Now that one's pretty obvious, because if I had to make x 0 at that point, the mx term would disappear and you just get y equals c. So why would we want to put the equation into standard form? Well, firstly, only if you're told to, and secondly, if you're given the equation and it's not in standard form and you need to know the gradient without sketching, then you would go for this format. So let's just look at a couple of examples. Okay, so here's my first example, and the equation is in the form y plus 2x equals 6. Very, very easy one, because the only issue that we have here is that I need it in the form y equals, which means that my plus 2x is in the wrong place. So obviously, if I take it across the equal sign, it's going to become negative 2x. The 6 didn't go anywhere, so it stays plus 6. And if I had to ask you, you would then be able to tell me that the gradient of this line is negative 2, and the y-intercept is very obviously 6. Okay, so that's my first example. Very straightforward one. My second one is if I have 2y equals 4x plus 6. This time, it's quite easy to be convinced that it is in standard form, because you've got the y term on the left and the x term and the constant on the right. But my problem here is that it's not in standard form because the y has a coefficient, and that's not good enough. So this is y times 2. So remember, how do you get rid of times by 2? You divide by 2. But that means absolutely everything on the other side has to be divided by 2. So 4x divided by 2 gives me 2x, and plus 6 divided by 2 gives me 3. And again, in this case, I can say, okay, so my gradient is 2 and my y-intercept is 3. So that would really be the point of me changing it into the standard form. Okay, so my third example, let's make life a little bit trickier. We have 3y minus 2x. Let's make it minus 5 equals 0. Now, very obvious, this one is nowhere near standard form, so we need to do quite a bit of work with it. Okay, but firstly, remember you want to start by isolating the y term. So we're going to move the 2x and we're going to move that minus 5 across to the other side. So that's going to give me 3y. Now obviously that's a negative 2x, so if I move it across it's going to become a positive 2x. It's a minus 5, so if I move it across it's going to become a plus 5. But no, I'm not in standard form yet. I still have that 3 in front of the y, so I need to divide by it. So we're going to get y is equal to, now if I divide 2x by 3, I don't really want to write it as 2x over 3. I'd rather just put the 2 over the 3. And the reason for that is it makes it easier for me to see what my gradient is. Okay, and then don't forget we still have to divide the 5 by 3 as well. Okay, so in this case, sorry, my pen's not writing very well. What do we have? We have the fact that the gradient is 2/3, and my y-intercept is 5 over 3. And that's really all you need to know about standard form. You just need to practice a couple of them.